Welcome back everybody, my name is Dustin, and in the last video we started this simple platformer where we loaded the map created from tile, and if they were colliders, we would add in a new physics component to the tile entity. Also, if there were triggers, we would add those in as well. So this worked out pretty good. However, now we need to look into the contact listener. You see how we go through this trigger here? Well, what we want is every time we touch that, we need data to come back for us so we know what it is, some type of information so we know what to do with this sensor, okay? Now there's many ways that we can do the contact listeners. However, I have a way that works for me. The first thing that we need to look into is the user data or user specific data. User data can be used in the B2 fixture, B2 body, and B2 joint classes. The user data can be attached as a uint pointer T. This is an unsigned integer type that is capable of storing a data pointer. That means we can use any type of user data and then just cast it back when we need it as long as we know what the type is. The problem that I found with that is there could be many different types that we may want to get the information from. So I came up with this. So we'll have this simple struct that we'll call the user data. The user data will have an std any object that will hold the user specific data. We will also hold on to a uint32t for the type ID. So what type is this data? We want to hold on to that data. So if you remember from the EnTT meta videos that we made when we were binding components to Lua, so right up here, if we check our bindings right here, so we have this EnTT type hash. So the type hash is basically just an ID type, which underneath that is a uint32. So if we just keep following this EnTT ID type, which the underlying data type is a uint32t. Okay, so we want to be able to use this so we have the ability to invoke the meta functions that we created earlier. That way, as long as we registered the type with EnTT meta, we'll be able to use the functionality. If we know the ID type, we can safely convert the std any, no problem. So even though we want to be able to set this up to use various data types, I'm only going to create a custom data type that what we will call the object data. And that will hold all the necessary information that we need. So this is the object data. The object data will just be a simple struct. It will have a string for the name or the tag the object may have, a string for the group the object may be a part of, a flag to see if the object is a collider, also a flag to see if the object is a trigger. So we want these flags. So think about like a locked door. It is both a collider and a trigger. And if we have a key, we can trigger the door to open. Then we'll just kill the entity from there, okay? And that will get rid of the physics component as well. It'll also have an std uint32 value for the entity ID. So we want to be able to access the underlying entity because you can't have a physics component without an entity. As long as we have the ID, we can get the entity and from there grab the components that we need. So once we have that, we can use the entity ID associated with the object and manipulate the object in our scripts. So we kind of want to make it like a two-way system. So Box2D holds on to the entity IDs for each body and the registry holds on to all the objects that are using Box2D. Okay, so the first thing I want to do is back in here, if we go into our physics and go in here, we just want to create a new UserData.h file. So let's say UserData.h, and then we're going to include any, include string. That's good for now. And we'll say namespace Scion physics. So the first thing we want to do here is make the user data struct, and it's pretty straightforward. So we just say struct user data, and we'll be using this directly in the contact listener. And then we'll have a std any, and that will hold on to a user data. So as long as we know the type, we're able to cast this data, no problem, okay? Then we'll have an std uint32t, that will be the type ID. I will just have that start at 0. So this is for the type hash from EnTT meta. And that's just the user data, okay? So now that we have the user data, we can create a simple object data struct. We can put this anywhere. However, my goal right now is just convenience, so we're gonna put it right here. So struct object data or data, and it's gonna have a string, std string for the tag, and it'll just be empty default. And the group also empty by default. And we'll have bool be collider. That'll be false. Be trigger. False. And then we're also going to have the std uint32t entity ID. All right. So while we're at it, we might as well make a toString function for this object data. And we'll just say no discard std string toString const. And we'll need a string stream for that. So we can include stream. And we can just say std string stream. Object data. So we want us to use std bool alpha. And we'll say tag try to keep this consistent. So tag group be collider trigger be trigger and the entity ID. Cool. And once we have that, we can just return our string. So return the string. Cool. So this is just for testing later on. So when we want to see that we're actually getting the data coming back. Now that we have these simple structs, we have the user data and we have the object data that will actually be our... You can change this if you like, but this is all I need for now. We can add things later. These next few episodes are going to be the ones that go over the contact listener. The whole point of these ones is just to get the understanding of how it works and how we want to do it, because we want to be able to grab everything from Lua. We don't want to have to touch the engine. All right, so let's create that contact listener class. So we'll do that in the same folder, physics, new, contact listener.h. And we're going to need to have our include the Box2D wrappers. And we also want user data. And now we can create our class. So name space Scion physics and class contact listener. Cool. So now that we have our class started, we need to inherit from the B2 contact listener. This will allow us to get the contact information back from Box2D. So we want to inherit public B2 contact listener. Cool. All right, and then we're going to have our private, and we're going to have our public. What's the first thing we're going to want here? We're going to want to have 2 pointers to the user data. So when we get back the contact information, that's going to be 2 bodies that are contact. So we want to say user data pointer mp user data A and user data B. Okay? And then we're just going to have a simple private function so that we can set the user data contact pointers. Okay, and then let's create a simple private function to set these contacts. So set user contacts is what we'll call it. And that's just user data pointer A, user data pointer B. These could just default to null pointer as well. Null pointer. Cool. All right, so since we are inheriting from B2 contact listener, there are 4 functions that we are going to want to override. And those functions are begin contact, end contact, post solve, and pre-solve. So let's go take a look at this real quick. Okay, so we have our B2 contact listener, and we have these virtual functions. You see how it says B2 not used, B2 not used? Well, we want to override these functions, okay? So we want the begin contact and end contact. These are the 2 that we really care about right now. We're not going to do anything with the post solve and pre-solve for now. We're just going to worry about beginning contact and end contact, okay? But we still want to override the other ones just so we have them. So let's do the begin contact, void, begin contact. The begin contact and end contact functions both take in a pointer to the B2 contact. So we say B2 contact pointer contact. Now this class manages the contact between 2 objects. If we go here, so yeah, see, it manages it between 2 shapes, sorry. So there's lots of stuff that we can get from this. So it has a pointer to the manifold, is it touching, enabled, get next, like the get next contact. But we don't need all that. We only care about the fixtures, and that's what I care right now. So fixture A and fixture B, okay? So that's what we're gonna worry about. So let's go back into here, begin contact, copy this again. This will be end contact, end contact. And then we're gonna have post solve and pre-solve. Void, post, solve. That takes in a B2 contact, pointer, contact. And then this takes in a const, B2, contact, impulse, pointer, impulse, override. I'm going to put override for all of them. And then pre-solve. Now pre-solve doesn't take the impulse, it takes in the B2 manifold. Manifold. Okay. This is the old manifold. Now we're not going to worry about these 2 functions right now. We're going to make them, but we're not going to worry about those right now. We are going to worry about the begin contact and end contact. So we also need to have getters for the UserData. We just want to return a pointer to the UserData. The raw pointer is fine. We're not considering any ownership here. We're just sending it, and wherever the pointer came from, that's where the data will be destroyed. So we're not going to hurt anything here. So we can just go UserData pointer, get UserData A, return MP UserData A. Change this to B. Cool. And let's make all these functions. Go back. Let's try this again. Make all of these. Create. And we will just go namespace, Scion physics. All right, so we'll just go from top to bottom. All right, so the set user contacts function is really straightforward. All we're doing here is setting our pointers that are passed in. The user data, MP user data A is equal to A. MP user data B is equal to B. Cool. Okay, so for the B2 contact, we use the B2 contact class that we have here, and this will have all the information that we need to get both the A and B contacts. First thing we want to do is a reinterpret cast of the user data for the contacts for each fixture user data pointer. So we go user data pointer A data is equal to reinterpret cast to user data pointer. And then we want to go contact, get fixture A, get user data, pointer. Cool. That's it. I guess we can do that all in one line. And we want to do the same thing for B. B data, get fixture B. Cool. And once we have those, we just want to set the contacts. That's all we want to do. So set user contacts. And that's just A data, B data. And then down here for end contact, all we want to do is set these to null pointer. So they're not pointing to anything. And these are just to do. So since these are set to null pointer here, that's how we're going to determine that the objects are not touching. There are many ways that this can be done, so feel free to make changes the way that you want. But for now, this is all I need. So I just need to know that current contacts have this user data, okay? And then since this user data contains any, it has an std any, and we know the type, we can actually determine the type from the pointer using EnTT meta, okay? All right, so now that we have the contact listener started and the user data started, we need to make some small changes to the physics component. So let's go to that now. Up here, ECS, components, physics components. We might as well open them both. Okay, so physics component. So up here, we're just going to include our user data. And we're just going to add in a Scion physics object data to our physics attributes, the object data, our data. Again, feel free to change the data to whatever you want. I find this works for me if I just have the data, the name, what it is, and I can work with it from there. As we get deeper in, you'll understand why I went this route. It does work. However, there's many ways to do this, so feel free to make any changes that you want. Okay, so down here, so now we just want to have another shared pointer, but this time it's a shared pointer to user data. Scion physics user data MP user data. Cool. And since we're here, we might as well make Scion physics user data, and we're just going to return the pointer get user data, return MP user data dot get. Cool. And if we go into our physics component.cpp, and let's just default our MP user data and just have this default to null pointer. Okay. And right before we create the fixture down here, let's create our user data. So create the user data. Okay. Let me say MP user data is equal to std make shared user. Oh, it's not that easy. So up here, let's actually use our namespace using namespace Scion physics. Then we have our user data. Beautiful. So now we want to set our user data. So MP user data dot, sorry, pointer to is equal, user data is equal to m initial attributes dot object data. Okay, and then we want to set our type ID. So MP user data dot type ID is equal to EnTT type hash of object data and the value for that. Okay, and that's it for this part. So all we're doing here is setting our any to the object data and setting the type ID to the object data type hash. Okay, now again, feel free to make changes to this. Like if you have your own data type that you want to use here, then feel free. And right here for the fixture def, right before we finish, we want to say fixture def dot user data dot pointer is equal to reinterpret cast uint ptrt mp user data. Okay. So what we're doing is we're reinterpret casting this into a uint pointer t of the user data pointer itself. Okay. All right. All right. So since we're here, we might as well do the user bindings for the object data. So in it right here, we go Lua, because we're going to need this in the physics attrib. So we need to have this already bound by in Lua. User type, object data. That's going to be object data. It's going to have a type ID. Type hash. Object data. Value. Then sol call constructor. Sol factories. And we're going to have two ways to do this. One way where we send in each value, or another way where we use a sol table. So lambda const std string tag const std string for the group, bool for the collider, bool for the trigger, and the std uint32t for the entity ID. Cool. Let's bring this down a line and bring this over, and we can just say return object data tag is equal to tag, group is equal to group, collider is equal to b collider, b trigger, b trigger is equal to b trigger, and the entity ID is equal to entity ID. Cool. And we're going to have one more, and this one is going to take in a const sol table reference object data. And we will return basically the same thing here. So we just copy this, return it, but we have to adjust. So this needs to be object data at tag get or std string. And we basically want to do the same thing for the group. Just change this to group. Same thing for the collider, but this changes to bool. So get or false. The collider. B trigger. Or the entity ID. So this one would be entity ID, get or, and then we need to cast this std uint32t 0. Now you can have in EnTT 0 is a valid entity ID, so we may want to change this later, or have it be EnTT null. Let's try. If that doesn't build, we'll set it to 0. Okay. Now the only thing I want access to is the toString function. For now, feel free to add the other data members. However, I do believe that they should be changed using a function only, so we can actually change the underlying data. But we'll get into that later. I only care about the toString right now. Okay. So now that we have our object data bound, we can come down here to our physics attributes and add that in. So we go here and just go object data, physics attributes, object data. And then we can have, instead of doing this regular empty constructor, we can have an empty constructor, and we might as well add another one in, but this one's only going to take a sole table. Now there's a lot of stuff here, so I already have this done. So we're just going to do this here, copy it over and bring it over, paste. All right. So all this does is takes in a sole table for the physics attributes, and it takes in all these values, E-type density, spelled the exact same way. And if the value isn't there, it just provides a default value for us, okay? All right, we're almost done for this video. We're not going to be able to finish the contact listener in this video. It's going to take more than one video. Okay, so but now that we're done that, we can actually start doing our user data bindings, and we can do this in the scripting folder. So let's go there now. Go over here to our scripting, add this in, new, header, user data bindings.h. So what we're going to need to do here is include sole, and then we're going to need our user data, include physics, user data, and then namespace, Scion, or I believe it's scripting. Let's make sure that's what we named our scripting namespace. Yeah, it is. Okay. And then we're going to have our static void create Lua user data sole state reference Lua. We're also going to want the ability to register the user data. So we're going to want to be able to register it with meta. So we'll have another template type name data, just in case you want to use a different data type. Static void register meta user data. Cool. But before we do that, let's wrap this all in a struct. And we'll call this struct user data binder. And then right outside of the struct, we're going to create the little helper functions that we need. So template type name data. And this one is going to be the auto create user data. That's going to take in a const sole table reference data sole. So we want the current state, current Lua state. So this state. Cool. And then we're also going to want to be able to set the user data. The set user data function will take in the user data as a pointer from the physics component and then convert the passed in sole table into a valid data in its registered type. Okay, so template type name data, and we're going to say auto set user data. This is going to take in a Scion physics user data pointer user. I say p user data. I need to be more consistent. Const sole table reference of the data that we want to change it to, and then the state itself. So this state s. When we want to get the user data, we need to take in the user data and then cast that data to the correct type and return it to the user. Okay, so the user data is just a pointer to some data, but we need to get that data and pass it back. So that's what we're going to do here. So it's just template type name data auto get user data Scion physics user data reference user data. So this state S. Cool. All right, so let's create the new .cpp file for the create Lua user data. Okay, and let's go back. So now I don't want to create these template functions in this file. I want to create a .ini file. So we'll do that right now. So let's create the .ini file for the template functions. And we might as well, you know what, we might as well include that now. So here, include user data bindings.inl. It doesn't exist yet, but we're going to make it. Okay. Go here to our scripting, add new .cpp, UserData.inl. Okay. And let's copy all of these, and we want to put those in here. However, the first thing we want to do before we copy is include user data bindings, include entity, and then we'll say using namespace Scion physics, sorry, and then namespace Scion 4 scripting, and then paste these in there. You can get rid of the static here. Copy that. I want this down at the bottom. And then this is the user data binder. Move these over. Sorry about that. This should have this. Okay. So like always, we might as well just start from the top and work our way down. So for the create user data, the first thing we want to do is check to see if it's valid data coming in. So we can go auto, new data is equal to data.valid. If the data is valid, we want to just set it as the data type or just an empty data type. So now we want to create a new user data object. So we go user data, and then we'll say user data dot user data is equal to the new data. And it should already be set to, so basically just setting our any to the user data. So this would have created the data for us. If not, it would have created us a default value of the type coming in, okay? And then we want to set our user data dot type ID to the EnTT type hash of the data value. Okay, and then once we have that and the data is all good, we can return it as a sole reference. So let's go return sole make reference, sending the state and the user data. Cool. That's it for that function. So the set user data is basically the same here. We can just copy this. This is just the data we want to change it to. Okay, so then we say user data. Because we send in the pointer, we want to say user data dot reset. Then we want to say user data is equal to the new data. So right here, we're just resetting the any because it's an std any, so we're just resetting it back to an empty any object. Okay. And then we're just going to set the data, same as up here. So we just copy this. And then we want to return a sole reference of the new data. However, we are going to cast it to the correct data type on the return. So the above will return the new user data. This one here will return the new user data object. It will actually return a user data object, where this one will return the actual underlying object. Okay, so in order to do that, we want to go return sole make reference S for the current Solo state, or Lua state, sorry. And then we want to say std any cast data of the user data. So what we're doing here is we're casting this to the specific underlying data type, okay? And that's what we're returning. This one is returning a user data object, and this one is returning a object data, most likely object, or whatever the type is that you have it as. So the get user data one will most likely be used the most. The create and set user data should usually be done upon creation of the object, so they're most likely not needed as often, and the user data in our case most likely won't change. However, I wanted to add these functions in for more flexibility if we determine we want to use them later on. But the get user data, we're definitely going to be using this, okay? Okay, so the get user data is pretty straightforward. All we want to do is take the user data that is sent in and return the casted type of the desired values. Okay, so we go auto reference data is equal to user data dot user data. And then all we want to do is return basically this right here. We can just copy this whole line. And we're just doing the data. And that's it. Now, I should probably be adding in checks for bad casts. However, I think we'll be fine because if the type is not registered by EnTT meta, it will never actually reach this when using the invoke meta function anyway. However, if we find later that this is causing problems, we can add that in, but I haven't noticed it to cause any issues at the moment. All right, now the last template function that we need to do is the register meta user data. Now this will allow us to invoke these functions from Lua for our user data. We have used this a few different times when creating components, so it's pretty straightforward. So we want to go using namespace EnTT literals, and then we want to create the EnTT meta type. So EnTT meta, and the type is the data. And then we want the type to be EnTT type hash of the data value. Then we're going to have three template functions. That's these template functions above. So we can just say template func create user data of type data. Create user data HS. And we do this 3 times and just adjust, set, get, set, or sorry, get and set. All right, and that's it. We're almost done for this video. So let's go into the user data bind.cpp and finish the create Lua user data. Okay, so we're gonna need a couple things here. We're gonna want our logger, so include logger. And we're also gonna want to get the meta utilities, so include, and we right now have that in the ECS folder. We may want to move this later because it's going to be useful in other places, but we'll just leave it there for now. And then we can just say using namespace Scion core ECS utils. Or is it just ECS utils? Hold on. Just utils. Yeah, so that definitely should be moved somewhere else. All right, so creating the user bindings is similar to the other user types that we've all done. However, we want to make a call to those template functions and invoke the meta functions as needed, okay? So right here, we'll just say using namespace EnTT literals, and we'll say lua.new user type, and that is Scion physics. Actually, let's get rid of this. Let's say using Scion physics, and let's just say user data user data or data, and then our type ID. Now the type ID for the user data is different from the type ID member of the user data. This type ID is for the user data itself, okay? So EnTT, type hash, user data or data, value. So if we are going to create user data from Lua, we're going to want to call the create user data function. We're not going to want to actually have a constructor for this. So we'll just say create user data, and then we'd say const sol table reference, and that's the data, and it's going to take in the state. So this state s. Now it does that automatically. We want to return an object, so object. The reason why I'm doing this is sometimes the compiler can't deduce that's what we want. So sometimes you have to tell it exactly what you want. So the first thing I want to do is check to see if the data is valid. And you got to remember that this data has to be already registered with Meta in order for it to work. So we go data. So if it's not valid, we're going to want to Scion cert false user data provided is an invalid type, and then just return a sol lua nil t object. Cool. So if we're in debug, the assert will work fine. It'll just stop here, and that's what we want. However, in release, this will just return the lua nil t object. However, we can change this assert macro. So if you're in debug, use the assert. If not, log an error. We could do that instead. But we're going to leave that for now, but that's something that you could do. Okay, so if you remember from the entity bindings, we need to get the type ID and invoke the passed in meta function that we want it to run. So we already included our meta utilities. So let's say const auto maybe any is equal to invoke meta function, and that's get ID type. That's the data of the data. Then we want to the function that we want to use. So create user data HS, and then the data itself and the current state. All right. So this will return an EnTT meta any object. So we need to check to see if the meta any is valid, and then cast it to the correct sol reference, or return a lua nil object. So we go return maybe any dot cast to a sol reference sol lua nil t. So if the maybe any is not anything, we're just returning a nil object. If it is something, we're casting it to a sol reference. Okay, cool. So the set user data needs to take in the data that we want to change and the data that we want to change it to. Set user data here, user data reference, user data, right? Then we say const sol table reference, that's the data that we want to change it to, and then the sol state, so this state. Also, we want this to return a sol object. And we want to do the same thing as up here. So let's just check if the data is valid. And we can actually do the same thing here. We can actually do all of this here. Copy that, change this to set. However, this doesn't just take in the data, it also takes in a pointer to the user data. So we need to take the address and the data that we want to change it to and the state. Cool. And that should be it. So since it returns the meta any, we basically just need to do the same check as above. All right, and then one more, and that's the get user data. And then all we're doing is sending in the user data. Reference user data. So this state. Yes. And we can just copy this. Since we're not sending in any data, we can just copy this whole thing here. Get rid of the data, get rid of this here. We don't need that. We need static cast, EnTT, ID type of the user data, user data type ID. And since we're not setting in data, we can get rid of this, change this to get. Cool. And the return is the same. All right. And that is it. So let's just run this and see if it builds. All right, so it looks like we have some errors here. Use the data bindings. Not seeing this. Oh, I'm an idiot. You guys can just say I'm an idiot. All right. Let's try that again. Probably didn't need those inlines. That's okay. All right, cool. So that built. So we're 99% of the way done. Last thing I want to do is take our bindings and actually bind them inside of our scripting system. So let's go to our script system. Let's go to the top, scripting, user data bindings. And then go down here, right where we're doing all our scripting stuff, might as well. And bind that right here, scripting, user data binder. Create real user data, and it doesn't need the registry. Cool. And let's run this one more time to see if it actually builds. All right, so that built. And we forgot down here that we have to register our user data type. So register the user data types. So just in case in the future you want to change it to something different later, you have that ability. Scripting, user data binder, register meta user type, and it's the object data. Awesome. So that's registered, and we're going to build it one more time. No, so it doesn't like that. Type ID. Silly me. You guys probably saw that. Cool, it built. All right, so before I let you guys go, we want to do one more thing. So we want to go into our main.lua and see if this works. Want to see if we're actually making our calls to our meta functions and stuff like that. So let's go up to here, and you know what? Let's just comment all this out. So we don't want to load anything here. Comment this all out. All of it down to here. And then comment this stuff out. No, debug as well. Everything commented out, good. And down here, let's do a little bit of tests. Make this bigger. So right here, we're just gonna do a little bit of test data. So we'll just say test data, and we'll say local object data is equal to object data, and we'll say test tag test group, and then true and true. Now we don't know the entity ID, so we'll just send in 9919. Then we say local user data is equal to user data dot create user data, and we want to send in our object data. Okay. So now we could just grab this and get its stuff from it, but that's not the goal here. The goal is to see if we can get it coming back from meta, from the user data. So I want to say local object data, and we'll say 1 is equal to user data dot get user data. Okay. And then once we have the user data, we can print, because we created that handy toString function. We can say object data 1 to string. Okay, so what it should do is it should return this object data that we set to the pointer, but then set the pointer to do all that any casts and all that stuff. If it doesn't work, we need to find out why. Okay, so let's do that now. And we got an error, and that's fine. Get you, yeah. Okay, so make sure you spell things correctly, unlike me. Cool. Oh, that's correct. Object data to string, object data 1, user data, get user data. So this must not have worked for us. So now let's run it, and it'll give us an error. Okay, so yeah, 144, which is this. So this comes back as nil. So let's see if our function is getting called. Let's go into our user data bindings. Get user data. So if we run this, no. And I think I know why. So yeah, it's not even coming into there. Let's go to our user data bindings here. What am I doing wrong? So let's put this here, run it. So it does get called. So our ID type was set, yeah. Right there. Because I was sending the address of. You guys may have caught that. That's the problem with copy and paste, right? We actually want to send in a reference to this function, not a pointer. We only want a pointer here because I actually want to change the data. So let's go here. There we go. Perfect. So now we're going to get UserData function. Let's get rid of that breakpoint. Let's run it again. Cool. There we go. See, we have our test tag came back, test group, collider true, anti-ID is true. So that's not correct. So we got to fix that. And it's funny because you guys probably already caught all these mistakes. So let's go. That would be in the physics component, I believe. And entity ID. Entity ID. No. Why is it saying true? So let's go to our object data. Yeah. You guys definitely caught that. Entity ID. Cool. So that was fixed. And it should be, I think it's 9919. Is that what we set it to? Yeah, 9919. Awesome. There we go. So test tag, test group, set, true. Cool. So we can see that the create and get work. So now let's actually do the set. Make sure that works. So to make sure that the set works and that it's in fact changing, we want to go user data. And we want to go set user data object data. And then say new tag. Newer group. And then false now, true, and 1, 2, 1, 1, 2. So that's going to set the data. And if we just copy this, and then we want to print it again. Let's print a new line as well. And change these to object data 2. And it should show this first. It shows that we're setting our user data and then getting it. Okay. Bang, there we go. So it looks like our meta functions are working. Everything's working as in order. All right. Okay, so that's it for this video. We were able to get our contact listeners class started. We created the user and object data classes, and we added the user data type and object data to the physics component. We also added in their Lua bindings so we can create the objects in Lua. And finally, we started the necessary meta types and functions so we can easily use this functionality from Lua. It might not all make sense at the moment, and it looks like we did a lot of legwork. However, it'll make more sense in the next video and when we start adding in the Box2D raycasting capabilities that we'll get into later on. Okay, so in the next video, we're actually going to start the contact listener bindings so we can use this new functionality in Lua. And I have a little challenge for you guys. I think it's really good to have a little utility for the toString here. So maybe go through all the components and add in that function. So just add in the toString function. And you saw how I did it in the object data. So basically just copy that right here. So just copy the no discard string toString and just copy this and add that in. See if we can get that to go. All right. So that's it for this video. Take it easy.